the internet and make sure you can understand about the lightning phenomenon. I think already all of you already learned during your masa you sekolah dulu kan, okay? So I want to all of you recap back the lightning phenomenon, or you can refer to the internet so you can put your answer. Okay. Yes, for a while I think the internet quite slow.
Doktor ikut ni ya. Ikut tu doktor. Doktor kod apa doktor
Jangan. Okay, you can use the new code 12605576. You found it?
Okay doktor.
Okay, I give you 5 minutes so you can refer from the website or you can refer to the textbooks. So make sure you can rephrase. Okay, I want to all of you rephrase the statement in the internet or the textbooks. Okay, so I don't want to see any the similar answer here. Okay, you can try by your own. Okay, it's okay. Never mind if you get wrong. It's okay. Okay, nobody's answer here. Okay, lightning is an electrical discharge for the first answer here. Lightning is an electrical discharge caused by imbalance between the storm cloud and the ground or within the cloud themselves. Okay, a natural discharge of the electrical current between the cloud and the ground or within the cloud short duration and high voltage can reach several million volts. Okay, develop when the upper atmosphere become unstable. Okay, right? Okay, the limit character is 250. Yeah. Okay, lightning is a natural phenomenon which develops when the upper atmosphere becomes unstable due to the convergence of warm solar heated particle and column on the polar upper in air mass. The air mass during rising air current carry water vapor on the The collision of the opposite charge in the sky is responsible for lightning during the thunderstorm. The upper part of the cloud have a negative charge, which lower part have positive charge. Okay, lightning is a natural occurring electrostatic discharge during which two electrically charged regions, both in the atmosphere or with one on the ground temporarily naturalize themselves? Okay, anybody? Just have a 6 answer here. 7. Okay. Lightning is a natural occurrence that occurs when the high atmosphere becomes unstable as a result of the conversion of warm solar heat air currents. So we have a 40 student here, but only 7 answer here. So make sure you take part in this class, okay? Lightning is a sudden and small electrostatic discharge during the electrical storm. This discharge allows the charged region in the atmosphere to temporarily equalize themselves. When they strike an object on the ground, lightning is a naturally occurring electrostatic discharge during which two electrically recharged regions both in the atmosphere or with one of the ground temporarily naturalize themselves, causing the instantaneous release of the average of 1 giga. Lightning is a voltage between the cloud and the Earth becomes so high that stray electrons in the air are accelerated to the kinetic energy large enough to knock electrons out the storm in the air. Okay, lightning is a very quick electrical discharge that occurs between a cloud and the ground, between two clouds and within the cloud. Okay, right. Lightning is a natural occurrence that occurs when the warm solar heated. Okay, I think this is the answer, and most answer thing is you just copy from the internet, right? Okay, the called the upper air mass, causing the upper atmosphere become unstable. Okay, lightning is a natural phenomenon which develops when the upper atmosphere becomes stable due to the convergence of warm solar heated vertically air column on the cooler upper air mass. Okay, just 13 students answer this question. I think in this class they have just on my class without anything. Not take part in my class. Please answer. Okay. Yang lain tidur lagi ke apa ni?
Tak tahulah, sure.
Aduh, kelas korang ni bosan lah.
Ada je. Jam.
Apa, saya ajar fleksi, dia orang semua energetik nak jawab semua ni.
Seorang sekali je tu ni.
Ha? Apa ni?
Dia seorang sekali je boleh jawab, boleh buat
Semua sekali lah kena jawab lah.
Seorang sekali je boleh jawab
Seorang sekali sebab dia refresh.
Seorang sekali je.
Sir, mic on, sir.
Okay, right. So I think only 13 students just take part of my class. I think overall, I think still sleep ah. Saya masih tidur lagi buat. Okay, alright. So I continue my class. Okay, I continue my class. So about the for the last question, okay, about the lightning phenomenon. So the first most important thing that you must know is you want to understand about the lightning phenomena, you must know about the cloud. Okay, you must know the cloud. Okay. So without the cloud, you can the phenomenon of lightning is cannot be happen. Okay. So because of cloud, so the lightning will be happen. Okay. So how the phenomenon? So how the phenomenon of the lightning is occurred? So it start from the ground. Okay. This is the ground. I just draw. Okay. I take the. Okay. So this is the ground. Okay. So boleh nampak kan? Sekejap eh.
Nampak.
So slide ni tak ada dalam GC ya?
Ada. Boleh tengok dekat dalam announcement tu.
Alright.
Okay, so the lightning phenomenon, they happen is from it's happen from the ground. So what happened? So during the summer, okay, during the summer, okay, you can call as a hot ground here, okay, the hot ground and they will hit the air here, okay. So what happened when they hit the air? So the warmth of air will rise up, okay, will rise up to the top. And then what happened? So what happened from the air, the warm air is rise, and then they will turn from the hot to the cold temperature. Okay, from the cold temperature. So once they hit the cold temperature, they will become the small of ice. Okay. Okay, so from the small of cloud, and then they will become a larger cloud. So inside the of the cloud here, they have a small of ice here inside that one. So if you remember, once you do some experiment, you hit the ruler, okay, you apa nama, kita gosok pembaris tu, okay, gosok pembaris, and then you put in your head, in your hair. So what happened to your hair? Okay, they will produce the
Static charge.
the charge, right?
Discharge.
Yes. Okay. So therefore, actually they will produce the positive and negative charge. Okay, in the air, when the ice bonds with each other, okay, so what happened? They will produce the negative and positive charge. Okay, so it's inside the positive and negative charge, but the positive charge will place at the bottom of the cloud. Okay, the positive charge will place at the bottom, and the negative charge will place at the bottom of the cloud. Okay, so we have still the lightning phenomenon cannot happen because they have a large resistance of the air. Okay, because in the air we have still have the large of the resistance. So the accumulated of the negative and the positive charge, okay, the accumulated of the positive charge and the negative charge in the cloud. So what happened? Bila dah terlampau banyak sangat positive charge dengan negative charge dekat dalam cloud ni, dan they become a bigger, so what happened? Anybody can answer?
Unstable polarity.
Okay, so they become the unstable. And then bila sampai satu masa, once they have the limit, okay, they reach the limit, so they will discharge immediately. So that will happen of the lightning. Okay, so this is the process from the hot ground, and they rise up the air, the warm air, and they will become the cloud, and then at the certain part the warm air reach the level of the cold temperature, so they will become the ice, and then they will produce the positive and negative charge based on the bump each other of the ice in the cloud. Okay, they accumulated the positive and negative charge. Okay, they will become bigger, and then at the one time they have not the fully capacity of the charge, they will discharge immediately to the ground. Okay, this is the simple illustration of the lightning phenomenon. And then they have from the lightning we have two part, which is cloud to cloud, and then the one more thing which is cloud to ground. Okay, this is the category of the lightning. So they have another cloud. So what happened? They have a lightning from one cloud to other cloud, and then another one is the cloud to the ground. So any question? Do you have any question?
No.
Okay. So the category of the lightning can become the cloud to cloud and the cloud to ground. Okay, you can refer from my slide here. Okay, they have a category different type of lightning. Okay, they have a cloud to cloud and cloud to ground and the cloud to air. Okay, so about the category of lightning, the different type. So we have also the direct, stroke and indirect stroke. Okay, for example here, okay, we have one transmission line here. Okay, we have one transmission line here. So they have a cloud, and then the cloud stroke over to the transmission line. Okay, for indirect stroke, the cloud is not direct to the line. Okay, maybe they produce the lightning from cloud to ground, but it's not indirect to the directly to the line. So they just induce, okay, they just induce the line, and the for positive and negative charge will discharge to the ground. But this is still we call as a they also will affect to the our oscillation, our traveling time. So I think all of you already learned about the traveling time. So they will affect on our first the oscillation of power source, and then they will affect on the traveling time. So about the we return back to the direct stroke here. Okay, normally for the direct stroke, they will hit directly to the tall objects. Okay, so we also can prevent the direct stroke based on we can use lightning protection. Okay, we can use the lightning protection. Okay, so about the indirect stroke, okay, about the sorry. Okay, for the indirect stroke, it could be happen not only for the total object, but it can be happen at any place. But it is happen induced to the energy to the transmission line. So that will affect on the oscillation and the traveling time. So this is the direct stroke. So it can prevent by the lightning protection, but for the indirect stroke, it also can prevent for the lightning protection. But the some of the system, the lightning arrestor cannot capture the signal until they use we can use a relay. Okay, like we can use a relay to the trip of the power line. Okay, all right. So this is the comparison between the direct and the indirect stroke. But the indirect stroke, you must remember what the effect of the lightning, the indirect stroke compared to the direct stroke. Okay, so the dangerous of the lightning phenomenon. Okay, so they will affect on our building. We if we not install the protection system on the building, so they can destroy our building system, and maybe can directly to our trees, the trees, and maybe can directly to the people also. Okay, so for this, any question? Okay, for any question?
Oh, sir.
Tak ada?
Tak ada time.
No, sir.
Okay.
Saya sikit
So-
tadi ada beza primary effect dengan secondary effect ke?
Dekat transformer
Apa primary effect dekat untuk apa, untuk lightning tu kan? Dia kan ada direct dengan flashover tu kan?
Ya, betul.
So kalau secondary
Okay.
dia research dengan ground potential tu kan? Boleh tahu.
Ya, dia memang akan efek dekat kita punya transformer. Sebabnya bila berlakunya efek dari segi kita punya oscillating, efek dari segi dia punya travelling wave. So dia will separate they will split the signal. Okay, for example okay, they will split the surge signal to the our right, and then they will also enter the cable and then our transformer. Okay, so they will destroy the insulator, not only on the cable or the normally the line is we use the bare line. Okay, for the cable they will destroy our insulator in the cable and the transformer. So we will learn after this about the traveling wave and the reflection signal for the surge to our power line. Okay, so they will also affect on our transformer and our cable. So the another effect of the oscillation, once the oscillation is changed to other frequency, so it will also uh, destroy our equipment. Sama macam kita kat rumah, bila kita punya frekuensi, once the frequency is changed, so once our equipment is suit with the 50 hertz, so what happened to our equipment once the other frequency of our source is changed? Okay, so you can imagine what happened to our equipment. Okay, that's why we need to install the lightning protection and then the relay system on our system. Okay, right?
So jadinya kira kalau lightning dia strike dekat kita punya line tu kan, dia ada possibility frekuensi tak berubah ada lah.
Memang ada. Dia memang akan ubah.
Itu maksudnya.
Dia memang akan ubah. Itu kan memang efek dia lah, dua ni. The oscillation and kita punya travelling time. Okay? Sama kalau
Doktor,
ya?
kalau macam SPD tu pun function dia untuk lightning juga ke? Untuk protect device kita kalau macam SPD tu.
Apa? SPD?
SPD, Surge Protection Device lah.
Betul.
Oh, okay.
Okay, untuk yang tu kita akan masuk for the next part lah, which is the lightning protection. Okay, the lightning protection. Okay. Okay, so the SPD ni one of the equipment lah yang akan tangkap kita punya lightning. So ada dua jenis lah. So satu surge arrestor yang akan directly to the ground, and then ada juga yang latest punya equipment, dia akan absorb terus dia punya lightning tu, tapi dia akan terus rosak lah. Maksudnya kita kena do some maintenance to replace. Ya, betul. Kita kena ganti kita punya surge arrestor tu.
SPD bukan untuk protect barang-barang macam elektronik macam komputer. Tapi sebenarnya dia akan buh di MSB Betul kan?
Ya?
SPD ni dia untuk protect elektronik equipment lah, macam komputer, laptop kita semua tu kan. TV.
Yang tu kalau yang dia letak dia kepada kita punya pada equipment lah, yang tu pada equipment. Tapi yang kita nak belajar selain daripada kita punya equipment, so dia ada juga yang terus daripada kita punya transmission line tu. Macam tu.
Oh, di transmission line kita boleh letak SPD juga?
Device untuk?
SPD kita boleh letak di transmission, kita boleh letak kat line tu?
Dia normally dia akan pakai surge arrestor lah, surge arrestor.
Oh, yang saya letak SPD tu letak di MSB je.
Itulah yang normally yang dia panggil tu daripada surge arrestor lah. Maksudnya kalau kita dekat building ke ataupun dekat transmission line ke, ada akan letakkan satu surge arrestor lah. Okay. So SPD tu dia taklah directly terus daripada dia bukan yang capture terus directly kita punya lightning tu. Macam tu.
Okay, faham.
Okay, alright. Okay, so kita continue. Okay, kita punya part which is the lightning protection. So maybe you can enter the next Mentimeter slide here. Wait Okay, maybe you can share about the lightning protection. Okay, on this part. Okay, the code is same, 12605576. what is the lightning protection. Okay, maybe you can refer also to my slide and you can find some answer with the internet, in the internet. Okay, we have several answer here, which is the external lightning protection. Okay, LPS. Okay, help to preventing property damage from the consequence of the lightning strike. Okay, simple intercept a lightning strike and they provide a safe and effective path that take lightning harmful electricity to the ground. Okay, right. Protect this device from fire or shock. Okay, second. Okay. To protect our system from high voltage, use lightning arrestor and the lightning to the ground. Okay, lightning conductor guide the lightning. Okay, betul. To the earth and protect your home against the damage from and fire caused by direct lightning strike. They can seen on tower, mass and tall building. Okay, the function of a lightning protection system to protect structures, fire or mechanical destruction and to prevent the person in the building injured or even killed. Okay, the function of the external lightning protection system is to intercept, conduct and disperse lightning strike safely to the earth. Okay, without a system, a building structures, electronic system, people working around within it are all at risk. Okay, protect electrical and mechanical equipment from burn and broken. Also protect human from fatal. Okay, guard the lightning earth, protect against the damage of fire caused by the function of lightning protection system is to intercept, conduct, dispute. Okay, same answer. Protect structure from the fire mechanical destruction and to prevent that person building or injured, kill. The overall lightning protection system consists of external lightning protection. Okay, lightning protection system is designed to protect the structure from damage due to lightning strike by intercepting lightning strike. A lightning protection system can protect a structure from harm to protect electrical mechanical equipment from birth to protect from human fatal. A lightning protection system provides a safe pathway for energy from lightning strike. Okay, right. Lightning protection system designed to provide a low impedance, okay, part to the ground for potential strike. So in this group, siapa punya FYP buat pasal grounding system? Ada tak? Ada tak dalam group ni?
Saya.
Ashraf. Okay. Ashraf, you can share with your friends about the grounding system that you have been done. Any testing?
Saya buat external lightning protection design high-rise building, dekat high-rise building.
Cerita sikit. Cerita from start.
From start
Kita kejap.
Ceritalah firstly macam mana? Apa yang you nak kena design dulu? Which parameter? What the parameter that you need to design?
Air terminal dia, lepas tu down conductor dengan extermination lah. Dia ada 3 part lah. So
Ceritalah betul-betul.
air terminal tu dia ada equation dia lah kan. Dia ada mesh method. Lepas tu dia ada apa? Protection angle dengan rolling sphere method. So dekat 3 method tu dia ada ikut standard IEC lah 62305 lah. Dia ada 4 lah level 1 2 3 4. Lepas tu dia ada
Level tu untuk apa?
Level tu untuk
Ni bukan
class of LPS lah. Kelas dia, kelas lightning protection system lah. Dia ada kelas dia. So basically kelas ketiga untuk lightning bahaya dia lah. So dia ada size yang tertentu lah kita boleh pakai.
Okay, what the size of input you letakkan? Apa dia? Berapa size? Maksudnya berapa lightning yang you letak lah dekat situ berapa?
Mesh size dia apa?
Bila you nak buat testing, you mesti letakkan surge input tu, berapa surge input dia? Berapa dia punya amplitude dia?
Saya buat external lah. Saya buat grounding lah. Initial saya buat grounding je lah dulu. Untuk FIP tu lah.
Okay. Buat grounding kat tepi surau tu ke?
Bukan. Saya buat
Jalan
Tun Ismail.
Dalam?
Hotel. Jalan Tun Ismail.
Okay.
Hotel.
So apa parameter lain dari segi dia berapa impedance yang dia punya
dia punya react. Maksudnya macam mana tu?
Yang ni lah, yang target buat apa? Grounding
saya
tu.
kena below 10 ohm lah. Target dia below 10 ohm lah. Grounding kena below 10 ohm.
Kalau lebih daripada 10 ohm?
Dia tak sesuai lah. Sebab dia boleh musnahkan equipment dalam-dalam lah.
Okay. So the minimum requirement is 10 ohm, right?
Ya, 10 ohm. Betul.
Okay, so apa yang what is the challenge during you do the grounding system to get the below 10 ohm? Apa challenge dia?
Challenge dia below 10 ohm saya kena design tu kena banyak dia punya ni lah, kena pilih lah soil resistivity dia. Lepas tu dia punya diameter dia, panjang dia. Betul lah, aku lag.
Tubuh garam je.
Putus lah.
Lepas tu cara pemasangan dia lah, parallel ke series ke.
Okay, boleh dengar tak?
Boleh, boleh, boleh.
Okay.
Boleh, boleh.
Saya okay, selain daripada Ashraf, siapa lagi buat lightning protection system ke ataupun ada buat grounding ke? Siapa lagi FIP dia? Muhaimin. Muhaimin.
Tak, bukan.
Cerita sikit Muhammad.
Muhaimin share sikit dengan
Apa
kawan-kawan buat projek ni.
Bukan. Tak ada. Saya bukan buat lighting. Alif dengan Ahmad.
Alih dengan Abang Mat tu.
Alif. Alif dulu, kita bagi Alif dulu.
Saya pun tak buat lightning doktor.
Habis buat apa?
Saya buat dielectric.
Elektrik pula. Muhammad.
Saya buat ni lightning dekat transmission line, buat analisis je.
Okay, cerita sikit.
Cerita, Mat.
Tapi kalau lightning protection ni saya tahu lah serba sedikit untuk LV saya tahu lah sebab pernah buat kerja dengan ni.
Okay, tak apa. Boleh. Tak apa. LV pun okay.
Okay, selalunya kita akan design dua tingkat,
Ini
tiga tingkat kat atas lah.
Yang ni untuk commercial building lah.
Selalunya komersial ke tak kisah sekolah ke apa. Selalunya 2 tingkat kat atas tu kita akan buat lah dan kita akan tengok kawasan tu lah. Macamnya contoh kalau bangunan tu kita buat bangunan 2 tingkat je. Di sebelah kita ada bangunan yang 20 tingkat kan.
Okay.
So kita dan bangunan tu dia angle dia 45, bangunan kita save dalam 45% 45 darjah angle dia kan. So kita punya tak perlu buat lightning protection lah. Tapi lebih bagus kita buat lah.
Sebabnya kita tumpang lightning protection dekat tall building tu lah kan.
Betul.
Right.
And then kita selalunya kita akan buat dia lightning protection yang earthing system dah lain. Dia kita selalunya orang akan confuse lah. Lightning protection ni apa? Earthing ni apa? Dia lain. So untuk lightning kita akan pakai selalu kita pakai copper tape lah. Kita akan pakai copper tape di atas tu. Contoh kalau masjid ada menara masjid tu kita akan buat satu. Kita akan letak satu avenue. Kita akan ambil copper tape, drop sampai ke bawah. Habis tu kita akan tanam rod tu dan selalunya kita akan macam DJKR kita akan buat pakai catwell. Kita betul kita pakai catwell dan kita test lah. Sepatutnya result kita nak bawa 10 ohm lah. Yang tu yang terbaik lah. Kalau tak dapat 10 ohm kita kena tanam lagi satu rod lah. Selalunya kita akan tanam satu rod lah. Habis tu kalau tak dapat pun kita akan kena lay satu lagi lah. Kita kena lay satu tanam di tempat lain, kita akan sambung lah dia punya kabel tu. Macam tu lah. Tapi selalunya kalau tak dapat, dapat lah. Orang akan buat garam lah ayak sebelum tu kan. Garam lah pergi soil tu elok kan.
Tapi garam tu apa efek dia?
Garam tu dia tak tahu. Orang kata apa garam tu dia akan efek kat tanah tu untuk apa dia macam neutralize balik tanah tu.
Mengalir.
Itulah cumanya yang garam tu pun mungkin dia punya dari segi dia kekal lama ke garam tu? Sebab saya bukan orang grounding kan.
Saya tak pasti, saya rasa tak lama saya rasa tu sebab dia
itulah kan, mungkin kalau dia buat testing pun dah dapatkan 10 ohm tu mungkin ada certain period and then maybe for the next period tu kita tak sure lah berapa nilai dia kan. Okay, alright.
Tapi saya pernah tengok orang buat di atas bukit bukit memang susah dapat. Atas bukit memang susah nak dapat 10.
Dan mungkin banyak batu kot.
Betul. Sebab saya pernah buat satu kerja saya dekat sebelah MSB, bilik MSB. Katot memang tak dapat. Dari dia kena buat satu tanam di sebelah dia pelih kan. Dia kena lay balik. Dia pelih kabel tu lah. Sambung lah.
Okay, alright. Okay, thank you. Muhammad Ashraf, Alif tadi share kan? Siapa lagi yang FYP dia related dengan tajuk-tajuk on lightning ke?
Saiful Azmi.
Saiful Azmi. Dah FYP 2 dia mesti dah expert lah.
Betul, dia kata dulu diploma dia buat ni protection dia cakap. Seko.
Elok tu.
Mana
Cuba
tak
share.
ada. Dia tipu.
Share Saiful, jangan malu.
Saiful, aduhai.
Jangan kena ikut ilmu Bol.
Orang nak belajar ni pasal lightning.
Cepat Saiful. Mana Saiful? Hilang dah. Okay, so thank you semua yang share tadi. Jangan saya share kita dekat kita punya slide. Internet slow lah, payah pula nak ni. Okay. Boleh nampak lah slide ni?
Boleh.
Nampak slide saya bergerak tak? Nampak tak slide bergerak?
Tak bergerak.
Okay, so yang ni adalah okay. So we talking on the search on transmission. So yang ni this is the most important part lah on the search on the transmission line. Okay, so the hypothesis induced on the transmission line due to direct stroke and indirect stroke that have been explained before this, and the switching operation. Okay, the surge travel along the line at the speed of light. Okay, so saya pun already know about the speed of light, the travelling time that has been explained by PM. So this the velocity. Okay, in the line we have a signal speed of the signal in our transmission line. So they will affect the surge traveling on the transmission line. Okay, as they reach at the end, termination of the junction of the line, partly are reflected and transmitted. So once the traveling from the line to the cable and transformer, so if they meet, okay, reach or the jointing point, the signal, some of the signal will pass through or the transmit from the medium A to the medium B, and some of the signal will reflect back to the medium A. Okay, so according this one, this is the direction of wave that you must know. Okay, okay, for the first is the value of E here, the voltage here. Okay, the voltage and the value of the current, and then the transmitted wave. Okay, this is the junction. For example, this one the medium A and this one the medium B. Okay, normally the most important part that we must know, which is the impedance. Okay, impedance for the line A and the impedance of the line B. Okay, the impedance line. So maybe for the line, the value of impedance is same, but the different impedance when the line and other medium such as the cable or the transformer. Okay, so we must know the equation of the impedance here, and then the important part, the value of voltage, the current, and the value voltage, which is the ET, the transmitted voltage and the transmitted current, and then the reflected of the voltage and the reflected of current. So you must know the first part, the value of E and I of the transmitted. Okay, and then the second part, E and I, which is the reflected. Okay, this one the transmitted, and then the value of impedance here, Z1 and Z2 here. Okay, and then the other part that you must know, which is the value of the velocity here. Okay, and then the equation of velocity I will share after this. Okay, so according this one, you must know the equation of reflected and the transmitted. Okay, based on the slide number 32, we have we can use a reflection coefficient, which is for the reflected, and the value of and for the transmitted value. Okay, the transmitted value of is beta. Maybe you can write down to your notes the equation of reflection and the transmitted coefficient. We will use after this for the example. Okay. Saya minta semua salin dulu equation ni, alpha dengan beta tadi. Actually, this is the same equation, which is this is the value of alpha, and this one the value of beta. Okay, so based on this one, we can get the value of transmitted voltage and the reflected voltage and the reflected voltage. Okay. Okay. So based on this one, we need to analyze the transmitted wave or signal and the reflected signal based on the Bewley lattice diagram. Okay, if the to this slide, the 26 slide. Okay, because if you refer to the slide number 24, they have a certain part, the figure is a downhill figure. Okay, the downhill for the transmitted, and then the reflected, this one for the reflected. Okay, actually this analysis we can Bewley lattice diagram. So what is the properties of the Bewley lattice diagram? Okay, actually the Bewley lattice diagram to show the position and direction. Okay, the position or direction of the incident reflected and transmitted on at the very instant of time. Okay, so that's why the properties. Okay, this is the properties. The properties here is like a downhill, right? Okay, always travel downhill because the time increase. So maksudnya dekat sini, bila kita nak tengok dia punya, nak tengok dalam in a one medium here, okay, they have a wave velocity. Okay, they have a wave velocity. So from the point A to the point B, they have a traveling time. Okay, so based on this one, like the apa nama, fiber optic. Okay, like a fiber optic. In the fiber optics, they have a bounce wave, right? But so the time from the time 1 or the time 2 is same like this one, from point A to the point B. Okay, from the 0 to the T, and then from the another reflected signal, okay, the reflected wave T, it is same from the T, the next is a T. For example, this 10 microsecond here, and for this one is 20 microsecond, and for this one, the reflected back, which is the 3T, equal to the 30 microsecond, and then reflect back, this is 40, which is the 40 microsecond. The value of the voltage will is increase. Is increase. Okay. Okay, let's do this equation. Okay. Okay. Okay, masih boleh buka example satu tak? Saya rasa internet saya slow sangat lah, tak boleh nak, dia tak nampak dia punya pergerakan slide ni.
Slide kat mana Doctor? Kat GC tak ada.
Dekat dalam announcement, dalam tu ada tak? Okay, dalam ni example satu ni. Okay, simple je. Overhead which L equal 1.5 millihenry per kilometer, and the value of C, which is the inductance and capacitance, okay, 0.015 microfarad per kilometer is connected to the cable, for which L is equal 0.25 millihenry per kilometer, and the value of C 0.45 microfarad. If the surge of 10 kilovolt originates in the line and enters the cable, calculate the voltage current in the cable. Okay. Dapat tak nilai Z berapa? Ada siapa yang kira tak? Z1 361. Okay, Z2. Okay, so nilai I. So nak dapatkan nilai I berapa? Sama same apa equation macam Ohm's law tu. I equal berapa? I equal okay, berapa? Berapa jawapan dah? Okay. Satu okay betul ya. Okay, so ni value dekat sini lah. I dekat sini. So nilai I 2. Okay, nilai I 2. Okay, ambil nilai. Okay. So we have a reflected voltage and the transmitted voltage. So from point A to point B, okay, from the line to cable, okay, you use the second equation. Okay, untuk dapatkan nilai E2 ni. Ataupun kita gunakan E prime lah. Okay. E prime dengan juga I prime. Okay. So you need to find the value of the beta. Okay, remember if the transmitted signal is a beta and for the reflected is a alpha. So dapat berapa bila nilai E2 ni, E prime dapat berapa? Okay. Yeah, right. Titik peluang tak? I2. The point value. 58 point. Five. Okay. So masing-masing semua dapat Ada yang tak faham tak? Yang ni baru transmitted, kita belum masuk yang apa, reflected punya signal. Okay. Ada soalan tak?
Setakat yang tak ada lagi Dr.
Okay, clear
Okay.
Senang kan? Senang je kan?
Boleh Dr. boleh.
Okay, boleh. Yang ni dia baru basic. Yang ni akan challenge sikit lah. Sebenarnya kena pakai pen jadi senang sikit nak draw yang bilu lattice ni. Okay. So masing-masing boleh salin soalan dulu. Okay. Sebab kita cuba habiskan dalam sampai pukul 12 ni. Okay. So kalau nak senang, buat macam point saya tadi tu. Lukis dulu apa komponen yang ada kat dalam. Which komponen yang ada. Kabel A, kabel B. Apa dia. Okay. Okay, the end of long to transmission line A and B. Okay, maksudnya kita ada dua line A and B are connected by cable C. Okay, so all of you must understand the statement there. So cable A dan cable B dia bersambung dengan line A dan line B dia bersambung dengan cable C. So the cable C, they have a 1.5 kilometer long. The lines have, means here, the lines mean here line A and line B. The lines capacitance of 10 picofarad per meter and inductance is 1.6 microhenry per meter. Okay, and the cable has capacitance 89 picofarad per meter and inductance is 5 times or I think 0.5 yeah. Okay, 5 times the 10 power of -7 Henry per meter. A rectangular voltage wave have magnitude 10 kV and long duration traveling along line A to the cable. Draw the lattice diagram during 40 microseconds after the initial surge reach junction of line A and the cables. So according to this one, I just want to add some okay. What will be the junction? The junction of line A and the cable 20 microsecond after the initial surge reaches this point. Okay. So dekat sini bila kita draw, okay, bila kita draw, kita ada satu line A and then of course akan ada junction here and then akan ada satu kabel, okay, satu kabel and then ada satu lagi junction. So yang ni kita dia bagi adalah line A and this one the cable C and this one the line B. Okay, so for the first step, you must find the value of Z1. Okay, due to the line A and the line B, the impedance is same, so the value of impedance is equal to Z1 for line A and also line B. You can use the value of Z1 and the value of cable C, we can use the Z2 because due to the difference of impedance. So dapat berapa? What is the value impedance? Okay, Z equal 1 over LC. So the value E yang dia bagi dekat sini adalah 10 kV. Okay, so what is the value of Z1? Hafiz, dapat apa Hafiz? Ohm. Okay, 400 ohm. So the value is line A and line B is same. Okay, the value of Z2? $75 ohm. So now we can start draw the value lattice diagram. Okay, you can use same like this one. Okay, for the first step. So the first step you must meet the requirement, the properties of W lattice, which is the downhill. Start from the downhill diagram. Okay, for example, the input of E here is equal to the 10 kV. So what's next? So we need to find the value of the transmitted and the reflected. Okay, we need to find the value of transmitted and the reflected. Okay, So you can find the value of E prime. Okay, you still have beta. And you need to find the value of alpha here. Okay. You need to find the value to here. So the distance is 1.5 kilometer. Okay, what is the value of beta? Dapat berapa beta? Alpha berapa? Bukan transmit, and then dia adalah E reflected. Oh, ada pembaris dalam ni. Tak pernah cuba pula pembaris ni. Okay. Berapa tu? 0.3 untuk nilai beta. Betul betul betul. 0.3157. Okay. And the value of reflected alpha dia? Okay, betul. 0.684. Okay, right. Okay, so find the value of the voltage transmitted and reflected. Okay. Okay, the value for 0.684. Okay, so find the value of the voltage transmit and reflected. Dapat berapa? Asyik Hafiz orang lain tak ada ke? Reflected ke transmitted? Tak salah je. Nilai beta tu 0.3157 tu kali dengan 10 kV. Dapat 216 ke? Okay, so dapat 3157 volt. Okay, alright. Ataupun 3.15. 3.158 kV. So, value of reflected. Nampak tak kalau kuning ni? Berapa nilai reflected? Saya rasa nilai alpha tadi macam salah je. Nilai alpha kan? Alpha equal dengan, okay, so sekarang ni kita nak tengok dia punya medium yang kedua ni adalah kabel. So Z2 minus dengan Z1 over dengan Z1 plus dengan Z2. Z2 ni 75. Macam mana boleh dapat positif? Sepatutnya negatif lah kan alpha ni. 75 minus dengan 400 equal Z1 400 plus dengan 75 dapat negatif 0.684. So sepatutnya nilai alpha ni 0.684. So nilai reflection kalilah E kali dengan alpha tu dapat berapa? Dia apa? 6 tukar titik puluhan negatif 6.842 kV. Okey, sekarang ni apa yang kita nak kena tahu pula, soalan dia adalah nilai voltage selepas daripada 20 microsecond. So kalau kita reflect balik, once we reflect back to the previous slide, macam saya explain tadi, so dia akan from point A, from point junction 1 to junction 2, which is the cable, 0 to the E. Okay. So kalau ikutkan kat sini, dia dah bagi dah dia punya equation of velocity. Okay, V equal 1 over LC. Okay, 1 over LC. So nak dapatkan the time. Okay, so the equation is equal S equal to VT. Okay, means here V is the velocity, okay, and then T is the time, and S, which is the length. Okay, so you can get the value of T here is equal S over V, means 1.5 km over nilai LC ni. Sekarang ni kita nak tahu nilai LC, kita nak tengok velocity dekat kabel. So the value of NC must use in for the kabel punya value berapa. Okay. Berapa nilai T dia? Okay, first dapatkan nilai V dulu. Berapa nilai V? Every step ni markah tau. Pasal kita ada 10 minit je lagi ni. Where's the value of V? Tolong kira tak? Okay, nilai V. Okay. Nilai V tadi sama dengan 14996.3 km per second, and then divide dengan nilai T ni. So T is equal 10 microsecond. So dekat sini adalah 10 microsecond. So apa yang saya bagi tahu tadi, so for the next reflection ni, okay, for the next reflection ni, yang dekat sini adalah nilai 2T sama dengan 20 microsecond. So bila soalan dia kata after 20 microsecond, so kita kena cari dia punya reflection dia. Okay, dia punya reflection sampailah 30 microsecond. Kita akan cari nilai ET1, kita kena cari nilai ET2, dan kita kena cari nilai ET3. Berapa? So macam mana nak dapatkan nilai ET2 dan ET3 ni adalah based on beta dia still maintain saja. Sebabnya dia masih menggunakan reflection daripada joint number 2. So dia punya input based on nilai ET1. So nak dapatkan ET2 prime is equal ET1 prime times with the beta. So dapat berapa nilai? 3.15 tadi, 3.15 kali dengan beta 0.3 dapat 160. Betul ke? Nak calculator? Oh ya, silap. Dia bukan kali dengan beta ni. So dia kena cari satu apa? Reflected dia. Sebab tadi kita baru transmit. So kena cari nilai alpha yang baru. Okay. So ET2 times the new alpha. So kena cari alpha baru lah. Alpha dekat sini. Point ni. Okay. Jadi alpha 1. So kita dapatkan nilai alpha 2. So dia akan gunakan Z1. Sebab dia akan reflect dekat point ni. Z1. So Z1 minus with the Z2. Z1 plus Z2. Means 400 minus with the 75. 400 plus 75. And then times with the ET1. Cuba kira sekali lagi. So nilai alpha 2 berapa? .684 and then so this one nilai E2 2.160 KB. So nilai E3 reflected lah. Okay, so kita akan dapat nilai tadi tu E transmit. Yang pertama 3.15 kV and then ET1 transmit 2.160 kV ET2 1.47 7 kV, and then the last one so means here from 0 to T, and then from T1 to T2, which is 10 microsecond. So ada reflected 1, 2, 3 sajalah kan, 30. So, sampai E2 saja. Which is the 20 microsecond. So after 20 microsecond, from T2 to T3, 30 microsecond. Okay. So we need to find the value of ET. Means here ET prime plus ET1 plus with the E2 prime. Okay. So what the value? The value E total. Verify. Betul kan? Jangan salah je. Saya dapat lain dia. 3.15 tambah 2.16 campur dengan 1.47. Saya dapat 6.7. 6.787. Okay, alright. So in term of diagram, okay. So tadi ni ET. So tadi kita start dengan nilai ET1. And then jangan kita betulkan sekejap label ni. Transmit. So kita nak bagi dia confuse sikit. So first tadi kita dapatkan nilai ET transmit. Okay, so the next kita dapatkan nilai yang kedua ni. Kita guna reflect kan. So reflect. So kita gunakan E2 reflect. Dia akan jumpa 2T microsecond, and then yang ketiga okay, R1 R2. Okay, so yang ketiga ni lepas daripada 20 microsecond ni adalah 30 microsecond. So kita akan dapat the final value dia lah kat sini. So yang ni adalah ET E transmit pertama, and then dia akan reflect balik. Reflect pertama, and then dia akan reflect yang kedua. R1 dan juga R2. Okay. So settle sampai di sini saja. Ada sebarang pertanyaan tak? Ada yang tak faham tak? Ada sebarang pertanyaan tak? Yang tak faham?
Tak ada doktor. Nanti video di kelas hari ni doktor record letak dalam GC
Saya akan share.
Okay.
So nanti
Tak
okay, right. So nanti balik nanti tak payah balik lah kan, memang dah kat rumah dah kan. So nanti minta you all buat latihan example 2 ni, repeat dalam 2-3 kali. So make sure you understand the value, which impedance yang kita nak, yang mana kita nak gunakan. Okay, bila dia join jumpa kat mana, dia akan gunakan impedance yang mana. Okay, the value of alpha yang mana ataupun beta yang mana. Okay, alright.
Okay, sir.
Okay, so kat sini second tu boleh up to berapa ya? Okay, so dia akan depend pada soalan. Okay, so maksudnya dekat sini bila time lagi lama, so dia punya voltage ni dia akan attenuate dah. Maksudnya dia akan makin menurun. Okay, alright. So macam saya bagi tahu tadi, the value of V ni dia akan reduce. Okay, so maksudnya based on the time increase. So maksudnya bila lama-lama dia punya voltage dekat dalam surge voltage yang ada dalam kabel tu, dia lama-lama dia akan hilang. Okay, alright. Kiranya akan ada penambahan E ke doktor. Dia kalau kita nak cari kalau kita nak tengok selepas berapa microsecond. Semestinya kita kena tambah lah berapa voltage daripada 0 sampai 2T. Tapi kalau dia kata, soalan dia kata kita nak tengok voltage pada kedudukan antara yang selepas daripada 20 microsecond, berapa reflection signal dia tu. Macam tu kan. So kita akan tengok satu value je lah. Macam tu. Tapi kita nak tengok dia punya total, so kita kena tambah lah daripada awal sampai dia punya time ni. Okay, alright. Okay, kalau tak ada apa, sampai di sini saja for our class for today. So nanti saya akan ada share sikit untuk video part 2. Yang tu saya akan share recorded video sajalah. Okay, alright. So recorded video saya akan upload by end of this week lah. Okay, alright. So kalau tak ada apa, terima kasih semua dan selamat mengulang kaji. Buat balik latihan yang saya dah bagikan ni. Okay. So kalau tak ada apa, sampai di sini saja. Okay. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih semua.
Waalaikumsalam.
Salam doktor. Terima kasih doktor.
Waalaikumsalam. Thank you.
Waalaikumsalam.